Okay. So have you experienced some windows effect with the MOS VOC sensors, meaning seeing the signal output of the sensor increasing when the window is open and saturate for many hours per day to over 2,000 ppm equivalent? Also, the windows were closed afterwards?
Well, there were some events where there were very high concentrations, but usually these were very peaked events. Of course, we're not sure what was happening in the dwelling at that moment. Actually, we do have the window opening log for some of these houses, so we could check this. But we haven't processed the data in that way at the moment. The saturation of the sensor we did not see, at least not for multiple hours or days, as is suggested in the question.
Okay. How does the pressure difference over a building envelope affect to the VOC's measurements?
That's an interesting question. Again, we did not do a continuous pressure difference measurement in these dwellings, and the only intervention was on the ventilation unit. So I don't have any data on that. However, again, referring to the profile of the concentration, the VOC measurements follow more or less the CO2 concentration, but with addition of very high peaks. And I think these are more related to pollution events than to pressure difference, for example.
Okay, thank you. And I think we'll take just one last question, which is the ppm of VOC seem nearly identical for mode 1 and mode 2 on the first figure that you showed. How come? And we don't know how these emissions impacts are related to human health. How is it useful for use in practice? The same principles apply for CO2.
Yeah. These are actually two questions. Let's start with the last part. Indeed, we have no clue what the exact chemicals where these sensors, in this case, reacted to are. So how is it useful then? Well, the only way you can use it is out of a precaution. If you see a pretty high VOC peak, which we definitely had occurring regularly, then it might be a good idea, just as a precaution, to have some extra ventilation at that moment. For example, during cooking, during the use of the bathroom, showering, things like that. Now, the VOC seems similar during mode 1 and mode 2. That is true in the sense that there are high peaks in both situations, and the flow rate of the system was not of the order of magnitude that it was able to, let's say, overcome the peak. It could not keep the VOC concentration at a lower concentration by just mixing it away from the space. We were dealing here with flow rates of about 50 cubic meters per hour for space. So yeah, again, all it does is provide some extra fresh air at the moment where a peak like that occurs. And if you analyze the data a bit more careful, we could see that this makes that the high peak still occurs, but is ventilated away faster. So the decay is faster after the peak.